ഇവിടെ ബുദ്ധിയില്ലല്ലോ. Hello everyone and welcome back to my channel. Today I'm going to continue the discussion about sorting using sorting's use applications in computer graphics. So today we are going to take the example of contour plots. So what's contour plot? Let us first see in yes, so let us go and see in this article. This is an article from taken from Khan Academy from the course Multivariable Calculus. Yes, you can access this blog from Multivariable Calculus of Khan Academy Unit 1, where visualization of multivariable functions articles are written. In that, please contour maps. I'm going to give the link in the description box as well, so you can access it from there as well. So let us understand what are how contour plots or contour maps are made. You have this a contour map is used when you have a function which has two-dimensional input and one-dimensional output. Say for example, here example is given. Example of a function is given which makes a curve in three-dimensional space, which is f of x comma y equal to x power 4 minus x square plus y square. Here the problem arises that we here the problem arises that we have x power 4 x square with x variable which is independent of y variable. Generally, whatever plots we make in one dimension, actually in two dimension, x comma y graphs, there x is independent and y is dependent on x. But here x and y both are independent. Then how do we represent it in three-dimensional space? So in copy or a page which is two-dimensional, it's very tough to represent a three-dimensional graph. But then there the comes this graph into picture where you can represent the three-dimensional graphs using two-dimensional paper. That is using the x and y input in the paper. In the paper, we are going to plot x value. We are going to plot the x value and the y value both. Both on the same sheet, and the output will be represented as the curve. We're going to look into it, but first I open my Epic pen. Yeah. So yes, we were looking at here. Here in the yes, here in the graph. It is written that we want to plot x, y, and f of x comma y separately. So let us see how we can do that. Yes. So the x raised power 4 minus x square plus y square makes this kind of graph in 3D space. So we want to plot and we want to represent it in a two-dimensional space. Yes, by representing the two-dimensional space x and y, which is the input, is known as the input space. We are plotting the graph in input space only. Hmm. So what we gonna do? We plotted this graph in three-dimensional space where z represents the output and x, y represent the input. And then what we gonna do is we are making different number of different planes which slice this graph, that which and how we make a plane in this graph. We are taking any z value, say suppose z equals to 2, we take. Suppose we are taking z is equal to 2 in the graph, then in the z plane, in the z axis is going to represent a plane which has z value equal to 2. The all the points of x and y represent all the values which gives the output z equal to 2, and wherever it touches the graph means all the x y which is in the taken in as the input and also follows the graph relation, function relation. So a different number of z values are taken, say suppose from z equal to minus 1, minus 2, minus 1, 0, 1, 2 is taken in this graph as an example, and we take only that portion of the graph which is on this curve, below it's written here. Hmm. Here it's shown that these red lines represent all the values. This lines is z equal to negative 1, 0, 1 and 2. That is the planes which we saw just right now. All the other portions of the plane which does not lie on this curve are removed. So only these lines are the value where z is equal to, where z is equal to negative 1, and all the corresponding xy values are representing all the input value which gives the output as negative 1 and which follows the graphical relation which we are taking into consideration, which we want to represent in the graph. So moving down, if we project these lines onto a 2D plane, projecting all these, this loop, this different 8 kind of shape, this random shape and this random shape all together on one plane, then what we are going to achieve is called a contour plot, which is shown in the next diagram. Yes. So all these three-dimensional cut spaces wherever the particular z value is obtained from the on the surface by, yes, yes, are projected on this plane. So that is, if on the plot it's written 2, if on this graph you see that it's written 2 over here, it means the z value, that is the output, is 2, and all the x and y value which is on this circle is giving the output z equal to 2. And similarly, this 8 kind of shape shows us all the values which have value output equal to 1, and all the input values on here which is 1 comma, say suppose 1.5, somewhere in between here. This point, this input value will give the output equal to 1. So You might be thinking how these weird looking curves on the 2D shape may give me the notion of that 3D graph which we saw earlier. So here you have to notice in the space between two curves. This curve and this curve gives me the change in of output, that is output which is decreasing from 2 to 1. So all these value decreasing from 2 to 1, but 2 is the highest value. It means it will stay upward, and as 1 is lower than this, then 1 will come below 2. So there is a peak in here in this graph, and it looks like a mountain. It implies us, it gives us this notion, and all the values are 0, -1, -2. That is, all values are decreasing. So all the other values are also going to come down. So it's going to give this kind of surface. But how steep is the surface? The steepness of the surface is judged by this difference of these two distance between these two curves. As we move from 1 to 0, the space is lower. So we might be thinking, what will be the slope if the distance is longer, if distance is smaller, and the distance is further smaller and further small. It means change is not very rapid. So as I'm coming down, when distance is bigger, it means change is not very rapid. Change is coming down slowly. So, uh, yes. Yes. Sorry, I said a little wrong. In this figure, you can see, look at, this distance is larger, and then this is smaller and smaller. That is, the graph is steeper where the distance is smaller, and when distance is larger, the graph is having a slow gradient. So here this is coming slowly down, but when distance is lower, this is coming very fast downwards to the downward values. So this is like a very steep mountain coming overhead, then slowly it is going up like this. So we can have a motion, we can understand how much steep the graph is, whether it's a peak value, which we saw a mountain kind of surface, or whether it's a, say, suppose a tunnel like is something. Does this graph look something like a where okay, you can imagine a well here. We all have seen a well, where inside the well we all see that inside the well is dug deep in the ground, and it can be thought as a very deep tunnel inside the earth's surface. So how do I understand by only looking at the contour plot whether the graph shows a peak value, which is something like a mountain kind of surface, or a surface which is like a well that is deep buried in the ground? So I'm going to show you the next example. See, the deep dug inside tunnel can be thought of as a paraboloid. That is a parabola in three-dimensional space. So here is the function x square plus y square for this paraboloid. That is how this function tells me what kind of surface it is. I can give you a slight idea. So we all have learned in two-dimensional space that 2-degree functions represent parabola, and the equation x square plus y square, this represents a circle. So there is a number of circles like this you can imagine going on, but these circle size is increasing according to a parabolic equation. So it's like this parabola, and this parabola is revolving around in a circular fashion. So this gives a solid cone kind of shape, but it's not a cone. We can imagine it like a cone, but not a sharp cone. That is, parabola is being revolved in a circular fashion, which gives us this kind of surface in three-dimensional space. So here you are listening. So as we did earlier, we are actually taking plane value which has different z values and which is parallel to each other. So we are increasing z, only increasing z, and we are getting this kind of plots which we saw in the earlier example, and we are only taking the part of the plane which is cut by the plane only on the surface, all the points which were on the surface of this graph, not all the points which is going inside as well, only the points which is on the surface of this curve paraboloid. As being on the surface implies that this the all the points is satisfying the relation which we have judged. So yes, you can see different sized circles which is not drawn very properly by me, but in the lower graph contour plot you can see that it's a perfect circle. So let me erase this part so you can clearly understand the contour plot. And here I know that this is something which doesn't have a peak above but have a peak below. So how I can understand by looking at the curves of the contour plot that this is something which is having a minimum peak, not a maximum peak. Peak. Hmm. See, in the below graph, Here is the value which is represented by all the curves of z values. So you can see the z value is increasing. That is 1, 2, 3, 4, 5. It's increasing. It means that the lower circle is going to come down and the upper one is going to be larger, something like this, and the other one will be even larger, and the radius is also larger than the below circles, so it's coming something like this. And you can understand it's something like this parabola kind, as radius of the circle is increasing. If you can imagine, if we had a circle which where the radius of circle was not going to increase, then it would have been constructed as a cylinder in the three-dimensional space. So, carefully looking at the curve values, that is the z value, you can understand whether this function has a maximum peak or a minimum peak, which is like this: if it's dug deep inside on the earth's surface, or it's above or it's rising above like a mountain. And as we can see, the circle's distance, that is circle distance, is not small or big, it's uniform. So it implies that the curve's value is changing uniformly. That is not having, somewhere it's not having a deep, that is a slow curve, and somewhere it's not having a steeper curve. All the time it's smoothly, that is moving with the same constant value, increasing with the same value. Similar kind of, almost similar kind of, a little bit differences there in all the steps. So let us see a real life contour plot. There is some example of sine curves as well, which is showing, this one curve is showing a high rising peak, and one curve is showing the buried underground peaks. You can see mainly there is a above rising and one below rising. That's only shown here. And then if we see in a linear plane, then we see different kinds of lines. As when we are going to cut for different values, it's going to cut for a slope of a line. See, here it's going to be cut, and whatever line is on this plane is being drawn. Say z equal to 1 for z equal to 0. I'm sorry for not having a very good straight line, but all the make the part which touches the surface of the curve, which is on this plane. So this is showing this kind of steep increasing values. Hmm. So yeah. Hmm. So what, that's what we are seeing, different parallel lines. That's why, which is having 7, 5, 3, 1, -1, -3, -5, -7 as the z output value. So this is an example of a, I can say, the crater of a crater, shape of a crater on the moon. That is, we see a different kind of dug holes on the surface of the moon from Earth. So it's an example of one such hole. And how am I able to understand its hole? You can see it's 7628 Z value, and then the next Z value is 7650, which is increasing, and 770, which is again increasing, and 7725, which is further increasing. Then it's increasing, so it's a it's a dug hole with whose deepness, that is whose steepness of the wall is decreasing as it's moving up, as the difference is getting larger or small. So that's all from my side today. In the next part, we are going to discuss how I am giving this example in the as for an example of CGVR, sorting of images. So thank you. If you like this video, then please like our video. If you love this video, then please subscribe our channel for coming of our further parts. Thank you.